Okay, we have here today a really interesting integral that was suggested in the comments by Dan Depp. We've got the integral from 0 to pi of x ln sine of x dx. And you may notice this integral is actually really similar to the problem I did about a week back, and that's what this is based on. And I actually want to cheat a little bit and use the answer I got from that other video to help us along with this one. Okay, so in that other video, we just did this integral, just natural log of sine x, and you'll notice the difference here. The only difference here with our problem is now we have an x and we've changed our bounds. Now we have pi instead of pi over 2. And also I have the solution here from this other video, so what I'm going to do is we're going to use that solution later on in this one in order to solve this problem. And what I want to do to keep track of what we're doing is I'm just going to label my integrals to get started. We're going to label this integral we're working on as I. In the integral from the previous video, I'm just going to label this one j. And to get started with our problem, what I'm going to do is a u substitution. We're going to substitute u equal to pi minus x, just using the bounds. The sum of the bounds are 0 plus pi, or pi. And then of course I can solve for x, so x is going to be pi minus u. Taking my derivative, dx is going to be just minus du. Then we'll go ahead with the substitution. So I'm just going to plug in here for x, we'll plug in pi. Pi minus pi, we'll have a 0 for the upper bound. We plug in a 0, we're going to have a pi for the lower bound. Then our x value is just going to be pi minus u. Okay, so we'll bring that out front. Natural log sine, again substituting, we're going to have sine pi minus u, and our dx is going to become minus du. Then of course I can take this minus sign and bring it out front of the integral and use it to swap my bounds. So we're going to get this back to an integral going from 0 to pi again, like our original. Then next, one thing I just want to notice here, sine of pi minus u, what I can do with this is actually use the supplementary angle formula. The supplementary angle formula just tells us that sine of pi minus u is going to be the same thing as just sine of u. But from here, what I'm going to do is a variable change. I want to get this back to x because I'm going to be trying to add some of this stuff back to our previous integrals. And so we want it all in the same variable. And because it's a definite integral, that's not a problem. I can change it to whatever variable I want. So we choose x and just rewrite this thing. Now from here, this pi minus x value is just a little bit awkward. Pi is just a constant that we could bring outside of the integral, but not in this form. What I want to do actually is, what if I distribute in this natural log? By doing that, then I can split this into two terms and split it into two integrals. So let's see how that looks. Okay, now we have it broken up into two integrals. You notice, like I said, we brought our pi out front of the integral here. That's nice. This is actually pretty similar to our j, except for we still have the pi. We don't have the pi over 2 for our upper bounds. But over here, you'll notice that this piece right here, this is exactly our original integral. This is actually I. And because this whole thing is I, what I can do is actually just add an I, or add this whole integral on both sides. So let's say if we just add an I on the right side, we'll add an I on the left side. This is going to give me over here, we're going to have 2i, and this is going to cancel here. And so we just need to solve for this piece over here. Okay, now at this point for me, this is actually really interesting where we have the situation. We have the situation where we have this upper bound pi, and over here we have the upper bound pi over 2. And if we could just change this bound, we already know what the answer is. Well, I just did a video not too long ago called Almost King's Principle or something like that. And there's actually a formula that allows us to reduce this bound in like 2 seconds with a few checks. But I'm actually going to do it out just to make it really clear. So how I'm going to do this is we'll have our pi out front still, but I'm just going to break up our bounds and repeat the integral. So what I can do is I can write this as going from 0 to pi over 2. But at this point I've really changed it, right? But what I can do is write another piece. We'll still distribute in our pi, but then we'll cover the rest of the bound. We went from 0 to pi over 2. Now we need to go from pi over 2 to pi. But by doing it this way, we actually have one integral now that we can solve. We still have another problem, but we have this one that we know is j, and we know what j is. So for this one, we're all set, but we have to figure out what to do with this one. Well, it turns out that this integral is not bad either, because we can do a u substitution on this, and we actually just do the same substitution we did originally, which was u equals pi minus x. We're just doing the exact same thing, so let me just write all that down. So I copied down this part, which is pi times j, then we're gonna have our pi, and then we need to do our substitution over here. So plugging pi in is gonna give me 0 for the upper bound. When we plug pi over 2 in here, we're just gonna have pi over 2. Then this is gonna do the same thing we saw last time with our natural log. We're gonna end up with just sine of pi minus u. We'll do the exact same thing, just using the minus sign to swap our bounds like we did before. So now we're going from 0 to pi over 2. And like we determined the other one, sine of pi minus u, supplementary angle formula, this is going to be the same thing as sine of u. But now at this point, you could do a variable change to get it back to x, but we really don't need to, Because it's a definite integral, this is actually the exact same thing as this. So this is actually our j value again. So now at this point, we just need to put all the pieces together in order to finish this off. So just to summarize, we have here 2i on the left side. We have pi times j, which we found was this thing. And then again, we have another copy of pi times j. Adding that together is just going to give me 2 pi of j equals 2i. But of course, we can divide by 2 and cancel 2 on both sides. So now we've isolated our I. This is the integral. This is our original integral that we want to find, is pi times j. But now is the point where we can take our answer and plug that back in. So multiplying this together, we're just going to have pi times this thing, which is natural log 1/2 pi over 2. And I can just clean this up. Pi times pi is going to give me pi squared over 2 natural log 1/2, and that's it. Kate thought it was a really good one today. I'm kind of glad I was able to use this previous solution so I keep my video under 10 minutes. So we'll stop it there. Thanks again to DanDep. Thanks everyone for watching. Have a great day.